Hello everyone, welcome back to OneTouchBI. My name is Saravanan Vajravel and today in our class we are going to learn and program from scratch how to count the number of vehicles that are moving on the road using the object tracking with OpenCV and Python programming. In this exercise we are going to use our previous tutorial that how to extract or create the foreground mask based on the background model. With the help of that algorithm, we are going to solve the problem that counting the number of vehicles on the road. As you see in the picture, here is the video I have picked up. I'm going to make a reference line on the road, that is red line, followed by the offset line green above and below. Any vehicle that travels between the offset line, that one we are going to count as 1. That's pretty much we are going to work out in our today's tutorial. Without much delay, let's head over to my system. A quick recap on our previous tutorial. In the previous tutorial, we have seen in detail along with the code how do we extract the foreground mask from the background model with method 1 and method 2. Method 1 goes with simple concept, that is extracting the frame by frame, assigning the frame 1 and frame 2 and take a subtraction of frame 1 and frame 2. That gives the foreground mask, and later we converted that foreground mask with the threshold conversion, and finally we shown that image. Let's run that code. Method 1. Here is the output with the threshold conversion with absolute difference, that is frame 1 minus frame 2. Let's take the screenshot of this. In Windows, to take a screenshot of this, you have to press Windows key plus Shift plus S. Take the required screenshot. Go to your paintbrush. In my case, I already copied this. And this is what we are going to do in our today's tutorial. We are going to draw the reference line, the traffic line, followed by offset line. And how do you measure the screen resolution? Based on the screen resolution from left to right is width, top to bottom is height. So I'm going to make 3 reference lines. The red is the main traffic line plus offset I'm going to keep in the green line. Any line to be drawn, you need to have 2 coordinate points, x1, y1 and x2, y2. As you see, the x1 I'm starting at 220, 450. That is 220 is from left to right. What point of location you need to draw the line, and 450 is the height from the top. Similarly, from right to left side and the height, that is until 1000 with 450 height, the line should be drawn from x1, y1 to x2, y2. Over and above any curves which you see in the screen, those you call it as objects or contour. Every contour will have a bounding rectangle, and that bounding rectangle will be written in the form of x, y, width and height. In order to draw a rectangle, we need to have the left top coordinates, that's x comma y, and the bottom right coordinates, that is x plus width, y plus height, with nothing but bottom right coordinates. You need to pass point 1 and point 2 as a tuple for creating the rectangle. And the same way for line, point 1 and point 2 of the tuples. Okay, let's take this screenshot what you copied from the paintbrush. Copy the screenshot, go to your Jupyter notebook, introduce a cell right before the method 1, convert this cell to markdown from the drop down and paste the image. Just run this code like how others you trigger it by holding the shift enter or control enter. Run it, you got the image embedded in the Jupyter notebook, and this will be the reference for your remaining coding. Okay, so Now we got the reference image. All we need to do is we need to draw the reference trophic line, extract the contour, and make a bounding rectangle of each contour images. Let's go ahead and modify the existing code for the method 1. I need to introduce those reference lines right after the threshold conversion. After that, I'm assigning frame 1 becomes frame 2 and then repeat the loop. After this, right before the show image, here I have to introduce the block. So draw the reference trophic line. We have an OpenCV function for drawing the reference line cv2.line of, and within the open parenthesis you need to pass the image, that is nothing but frame in our case because we have taken the copy of the video frame into the frame variable, and that will be used for all our display purpose. Okay, we pass the first parameter, then the tuple we have to pass x1 y1 and x2 y2. The x1 y1 supposed to be in our case with our reference image 220 by 450, and similarly the second tuple is 1000 comma 450, the height remains same, and the fourth parameter is the color, which I'm going to keep red, that is BGR. The third value should be 255. After you make the color, you need to provide the thickness. We are good. We drawn the red line. Now we need to draw the offset lines. Let's do that. I'm going to draw two offset lines. The offset line is supposed to be with thickness 1 so that I can differentiate, and the offset lines are gonna be green, that is the middle value should be changed to 255, denotes green. One offset line I should draw right above the base red line, that is 440, and one right below the red baseline, that is 460. Let's name it as green offset below, and the other one is green offset above. We are good. Let's run this code. There you go. We did a mistake. At the starting, we have changed the y height, but in the x2 y2 side, the height is not changed. It was keeping the old reference. Let's update that. Can you see here? This should be changed to 450 and this should be changed to 460. There you go. It's proper now. Now what is that next we need to do? We need to extract the contours. In OpenCV, we have a function to find contours, that is cv2.findContours, and the image what we need to pass for finding the contour should be thresh image, the threshold image. Pass the thresh image followed by the second parameter cv2 return list or tree, you can use it, and the third method should be cv2 dot chain approximate simple. This returns you two parameters, contours followed by hierarchy. I'm not interested in hierarchy, so I'm substituting underscore. That means I'm not going to use it. Now you got the output contours. Once you have contours in your hand, You need to iterate in a loop until all contour objects are traced. For that, we need to introduce the for loop for C in cons, and inside the loop I have to show the contour anything which is having a contour area of bigger. Without that, let me show you, and then you will come to know why we need to use the contour area. So what I'm going to do, I'm gonna extract the contour bounding rectangle coordinates. The contour bounding rectangle coordinates will return you x, y, width and height. So x comma y comma width comma height equal to CV2 dot bounding rectangle of the contour, the first contour we are going to pass it. Once you have the x, y, w, h, now we can draw the contour rectangles, the bounding rectangles. Draw the bounding rectangles for all contours. Okay. We have an OpenCV function to draw the rectangle cv2.rectangle, and the frame, the image is frame. That's the one we are going to use for displaying the output. Frame comma, what is the second parameter is the left top coordinates, the tuple. The left top coordinate is nothing but xy, and the bottom right is x plus w and y plus h. We got x, y, w, h. Let's pass it. X comma y, x plus w comma y plus h. And what is the fourth parameter is the color. I want to make it as a green. That means 0 comma 255 comma 0, and the thickness supposed to be 2. I'm good. After I draw the rectangle, I want to have the rectangle with centered dot. In order to draw the centered dot, that can be drawn using the circle. Circle needs the center coordinate. So I have to find the center coordinate, that is x mid. X mid equal to, how do I find the x mid? X plus w divided by 2. X plus w, and the overall should be divided by 2, and this overall gives you in decimal fraction number. We need to convert to the round integer format. For that, I'm gonna introduce int of the entire output. Now the x mid is calculated. Similarly, we need to calculate the y mid, and y mid is in the same way, y plus h divided by 2. Now we got the x mid and y mid. All we need to do is just draw the circle. CV2 dot circle, and the image supposed to be frame followed by the center tuple point. The center tuple point in our case is x mid comma y mid, and the radius I'm going to keep it 5, and the color I'm going to keep it red, that is BGR 0, 0, 255, and the thickness I'm going to keep it as same as the radius so that it will be filled with red. We are good. Let's see. There is a syntax error. I have added a in the end. Let's remove that, and now it's good. There you go. You see now the trees are getting moved from left to right because of wind, and all those contours are captured. That's why you see too many contours and we are not able to see the clear bounding rectangle with the dots. So how do we avoid this? This I can avoid any contour that are visible in the long distance with a bigger contour area. Any contour area which are looking very smaller, I want to ignore that. That's where we are going to introduce the contour area. Let's press the Q key to exit from this. And now let's do this. I would say right after the for loop, I should introduce a check to ignore the small contours in size. For that, we need to use if condition. If cv2 dot, there is a function called contour area of the contour point. What is that? The first one you are getting C in the for loop. If cv2 dot contour area of C anything less than 300, I don't want to create a bounding rectangle and draw the circle inside the bounding rectangle. I just want to skip it. In that case, I have to make continue in the for loop. What happens with this? The remaining all lines will be skipped running it. It will just repeat the for loop. Anything which is greater than 300, only then these codes will start running it. We are good. Let's run the code. There you go. Now you see it is not creating the bounding rectangle anything which is less than 300. The 300 seems to be bigger. Let's make it 100. And now you see even more rectangles are getting created little far away from the traffic line. So we are good on this reference mark. Now all we need to do is we need to start counting the vehicles and printing in the top. So let's introduce the vehicle counter equal to 0, and over here in this loop after I draw the circle I'm going to keep a if condition. If the y mid, that is the bounding rectangle with the midpoint center circle, if anything that crosses the offset traffic line what we have created, that is greater than 440, and y mid less than 460, in that case I'm going to add vehicle counter vehicle equal to vehicle plus 1. That is what the plus equal to means. Now the vehicle counter is been initialized. Now we need to print the vehicle counter in the final original video right after the for loop is completed, before we display the original video. So let's introduce a statement to print the vehicle counter label. How do you print the vehicle counter label? We have OpenCV function cv2 dot put text, and the put text is going to take the image. The image is frame, and the second parameter is the text what we need to print. Obviously we need to print total vehicles, and open the flower bracket. With this we can combine the text output with the variable substitution. The variable in our case is number, so we need to convert this to the text format. Using the format option we can pass the variable the vehicle. We are good. And the third parameter what we need to pass is where exactly you want to print. I want to print in the top center of the screen. The top center is gonna be 450 comma, and it should be a tuple. 450 comma 50 is the y coordinate point, and the font face, the font I'm going to use plain font. And then the next parameter what we need to pass is the font scale. Let me have the font scale as 2, and the color I'm going to keep it white. The white can be represented with 255, 255, 255. And then the thickness we need to keep it, that's 2. I guess I'm done all required step. There you go. Total vehicle is printed in the top, and as and when the vehicles are crossing the reference line, the vehicle count is initialized. So this is on the method 1. Let's quickly simulate this on the method 2. So in the method 2, what we are doing, we are using the built-in create background subtractor function to extract the foreground mask, instead going through the traditional method of threshold conversion. So this entire operation, whatever we have done until here, it is all done with this one line command, background subtractor, and then passing the frame into the background subtractor and getting the FG mask. This FG mask is nothing but in the method 1 until this section, and including the threshold. Threshold is not required because we are using the subtractor function. So all we need to do is we have to retain the same code what we have done, drawing the reference traffic line all the way right before the Q key to be pressed and exit the loop. So copy all the lines and place it right after the FG mask and right before the Q exit. So I'm replacing this with the code what I copied. I'm good. And FG mask is used for finding contour, so that should be replaced. Copy this, replace the thresh with this, and frame, and the foreground mask is FG mask, and all are good. Now you run this code, it will run seamlessly fine, and there you go. And over here we are seeing lots of distractions other than the roadside images. How we can avoid it? That we need to fine tune this code a little more. Let's do that right away. We need to introduce the if check to make sure that anything which falls between the x1, y1 to x2, y2, only those objects should be marked with the bounding rectangle, and the remaining all we should not cover in our bounding rectangle detection. So in order to do that, in the second method, before we draw the rectangle, let's have an additional check. The additional check will have if x greater than 250 and x less than 900, only then I should focus on creating all the bounding rectangles and the other objects. So what is that we are trying to do over here? As you see here, I have made a restriction. Anything which is lying in between 250 to 900 in this width of the road, only those objects I should treat it as a validation check for the bounding rectangle and moving object detection. So that's what we are trying to do over here. Let's run this code. And over here, if you see, this is 220. The tree is coming under the X radar. So let's add additional check. What I'm going to do, if any object which is coming closer, that is a Y coordinate point, anything at this point, from there only I should draw the bounding rectangle. Anything which is sitting on the leftmost or top, that I should not consider for detecting the bounding rectangle. So that additional check I'm going to make. So that means X radar I kept it, and the Y radar I'm going to keep it. Y should be greater than the 450 point, right? From there I'm going back 200. That means anything greater than 250 in that radar, I want to consider it for drawing the bounding rectangle. Let's run this code. Now you see, though the trees are getting moved from left to right, that is not captured under the bounding rectangle. I'm taking a radar anything within the road at this point of time. Can you see my mouse cursor? Anything which is capturing over here, at that point of time, it is going to capture and show within our radar. Okay. I hope you like this tutorial. If you like this tutorial, I request you to subscribe the channel and give a thumbs up and share. Until I come back with another interesting technical video, this is Saravanan Vajravel signing off from OneTouchBI. Goodbye.